Military technology continues to evolve rapidly, and one area that has undergone significant transformation is the use of combat drones. From drones that were originally used for reconnaissance, these platforms have now evolved into sophisticated weapons capable of carrying out various missions. The United States, as one of the pioneers of military drone technology, has created a variety of combat drones that have shown remarkable capabilities on the battlefield. Two striking examples are the MQ-9 Reaper and the XQ-58 Valkyrie, which reflect the present and future of combat drones, respectively. The MQ-9 Reaper, first introduced in 2007, is one of the most famous combat drones in the world. Designed by General Atomics, the Reaper has versatile capabilities that allow its use in a wide range of missions, from reconnaissance to precision strikes. Equipped with advanced avionics systems, electro-optical sensors, and radar, the drone is capable of detecting and tracking targets from long distances. One of the main advantages of the MQ-9 Reaper is its ability to carry heavy weaponry. With 6 hardpoints, the drone can carry Hellfire missiles, laser-guided bombs, and other weapons. This allows the Reaper to strike targets with high precision without requiring the direct presence of a human pilot on the battlefield. The MQ-9 Reaper's role is not just limited to strikes. The drone is also used for strategic reconnaissance and humanitarian mission support, such as natural disaster monitoring or search and rescue. However, while these advantages make the Reaper an invaluable tool, it also has limitations, such as its dependence on ground control stations and its vulnerability to cyber attacks. Entering a new era, the XQ-58 Valkyrie marks a step forward in the development of the next generation of combat drones. Developed by Kratos Defense and Security Solutions, the Valkyrie is designed to be a more efficient and flexible autonomous drone than its predecessors. With the concept of loyal wingman, Valkyrie is designed to work alongside manned combat aircraft such as the F-35 and F-22, providing tactical support without increasing the risk to human pilots. One of the most prominent features of the XQ-58 Valkyrie is its ability to operate autonomously or in coordination with other aircraft. The drone is equipped with artificial intelligence technology that enables real-time decision-making on the battlefield. In addition, its stealthy design makes it difficult to detect by enemy radar, enhancing its ability to carry out covert missions. Another advantage is the lower production cost compared to traditional combat aircraft. With its modular design, the Valkyrie can be easily customized for a variety of missions, from attack to reconnaissance. This opens up new opportunities for the military to develop more flexible and cost-effective strategies. The development and production of combat drones such as the MQ-9 Reaper and XQ-58 Valkyrie require large investments. However, these costs are often offset by the operational efficiency they offer. In the context of the U.S. military, the budget for combat drones continues to increase as part of a strategy to reduce personnel risk and increase mission effectiveness. Production costs. Drones such as the MQ-9 Reaper have a production cost of around $16 million per unit, while the XQ-58 Valkyrie, designed to be a more cost-effective solution, is estimated to cost around $2 to $3 million per unit. This difference reflects the focus on mass production and efficiency. Operating costs. One of the main advantages of drones is their much lower operational costs compared to manned combat aircraft. For example, the MQ-9 Reaper requires only a fraction of the fuel and logistical support of a fighter jet like the F-35. Long-term investment. The U.S. military also sees drones as a long-term investment. With the ability to be upgraded through software updates and modular upgrades, drones can continue to be relevant to modern threat developments without requiring total replacement. Private funding. Companies like Kratos Defense are getting support from the private sector to accelerate the development of drone technology. This approach reduces dependence on government budgets while encouraging innovation. Economic effects. The drone industry creates new jobs and drives the growth of high-tech sectors. From manufacturing to artificial intelligence software development, the sector is the backbone of the modern military economy. Technological advancements continue to push the limits of combat drone capabilities. In the future, the main focus of development will include three main aspects: autonomy, human and machine collaboration, and sustainability. Autonomy. The use of artificial intelligence will be further expanded to enable drones to make decisions autonomously. This includes threat avoidance, target identification, and mission execution without human intervention. Collaboration. Future drones will be designed to work harmoniously with manned aircraft and ground units. Concepts such as loyal wingmen will increasingly become standard, enabling more unified and effective operations. Sustainability. In an effort to reduce the carbon footprint, the development of drones with environmentally friendly fuels and high energy efficiency will be a priority. In addition, the use of recycled materials and modular designs will help reduce production costs and environmental impact. From the MQ-9 Reaper to the XQ-58 Valkyrie, the evolution of combat drones reflects a paradigm shift in modern military strategy. While the Reaper represents outstanding efficiency and combat power in the present, the Valkyrie foreshadows a more sophisticated future, where drones can operate autonomously and cooperate with manned aircraft. With a focus on technological innovation and cost optimization, this direction of combat drone development will continue to reshape the future way of warfare, while delivering significant economic impact through cost efficiency and job creation.